I just wanted to give a review of what we did in the last 2 days and what we are going to do today. So in the first day, we spoke about general topics on on intelligent architecture, human-computer interaction, and also design process, especially in spatial design. And also, you started to experience extracting the relationships between spaces, I mean connectivity pattern and the space syntax using the existed plan layouts. And Muhammad told you about the abstraction levels that is available in this kind of extracting parameters from the plans, and also the depth level, and that is important in different plans. In the second day, we started with doing step-by-step the process of coding to generate a plan based on the step-by-step method that we have in Termite Nest plugin. And we also introduce some kind of controllers that you can have to control your spatial graph, and it can have impacts on your bubble diagram and the generated plan respectively. And also, the other thing that we did yesterday was introducing the evolutionary design process and how it can be combined with a termite nest plan generation. And you can use these methods in different steps, as we did yesterday, that it was used in 2 different stages in order to have some design goals and apply them. And today I'm going to just show you some slides about what we really mean by this evolutionary design that can help plan generation. Most of you would be familiar with what this means, but some of you maybe would need to hear it. So I'm just going to share my screen, okay? Evolutionary design solutions that can help us to find better solutions, or the solutions that is more related to our defined goals. And the definition of evolutionary design, just to name it a bit, is what happens in nature, and it works randomly to it's mostly about reducing the unfit genes and work on the process of generating new genes step by step. And at the end, we have optimal design solutions. But we should mention that not all the possible solutions are checked in this way, because it just tries to randomly keep some the best genomes in each step, and just make some offsprings and generate new genomes in each part. And at the end, as I told, there are optimal solutions. And we have a genetic algorithm which is based on this evolutionary design, and this is the same as I told, by combining the genes, making some interactions between them, and creating new offsprings. And what we need to do in optimization steps, we need to define our target, which is very important for us. And this is the method that we used yesterday. I'm going to also review what we did there. So the first stage is defining our target. In the second stage, we are going to define the parameters or the variables that could be changed to let us to reach the desired goal. And also we have to set the optimization rules, which we usually just use the default parameters, but we can also check the mutation rate and the offsprings and how genomes are generated in each step. And what we have in Grasshopper is one of the ways to use optimization methods in Grasshopper is using Galapagos, which is in this place in your Grasshopper screen. And it works as you see this the icon of Galapagos, the component of Galapagos, and how it works. It has a fitness, which is the target or the design goal, and it needs some genomes or variables that can be applied to, and they can change to find the design solutions. For example, in what we worked on yesterday, we had a plan, we had a boundary, and we wanted to place our spaces. There were 3 special spaces, and that we wanted them to be placed in our boundary so that they have the most view to the seaside, which we assume that this is the seaside. And so the user had this, for example, a design requirement or design goal that they wanted this plan to be generated in this way. And the next step would be what the parameters would be and how this can help us to reach our goal. And we decided to select these 2 edges, which are the most, which are closer to the seaside, and place our spaces near to these edges. And maybe the expected final plan would be something like this plan. And the parameters that is used in this way, which is called genomes, they need to be numerical values. So it's very important for us to design our algorithm so that we can have numerical data, and the Galapagos will change them to find the best solution or the optimal solution. And the numerical data within Grasshopper is GenPool, which have it in here. And we used it for our BIOS, and also using our slider, and using the combination of these components using different tasks, we can reach to our desired goal. And it works like this, as you see. This is not the case that we exercised yesterday, but it's just showing how Galapagos works and how the design outcome will be. And that's it. I just wanted to make a review and make sure that you are all following what we are going to do. And for today, as we described yesterday, we ask you to have design goals, and please define your own project, each of you, and start the process to find your design goals, the parameters that can be effective on this goal, and start writing your algorithm. I can stop sharing my screen. And before that, I'm just going to thank you all for your collaboration, and it's really is helpful for us also, especially for Mohammed, to make reconsiderations on the termiteness plugin, and your feedbacks would be really effective for us. Thank you all.
So thank you, Freshta, and thank you for the review. So as Freshta said, today we are going to ask you about the project we talked about yesterday. We said that you all please just thinking about the target that you want, and the methodology to implementing your target and do it with termite nest, and please share it with us to know how you're to understanding that are you okay with termite nest in this approach, and we will help you if you have any question, and we will learn from you also. uh, it's this interaction we have together, and we will and I will talk about a little about the implementing the second process of the subspaces. It is in the space that we set as a larger zone yesterday, and the Patrick said that he had error yesterday. I will doing a definition. I write a definition. I will send it to you, and talk about how it works. It's okay. So I think it could be better if firstly uh, we have your assignment and seeing what you guys are did with the termites in the generative design, talking about them, and then we are going to talk about the last topics, the how you can do the recursive process. For example, a definition that I provided for Patrick is a good example. I will talk about it a little, and then I want to show you another way that you can do another way of another way to providing the solution space, and how you can interact with the output of the spatial graph by yourself. And I just made it last night. I just was thinking about how is the other way that you can do new kind of collaboration and do and increasing the user defined solution for users. So I just want to talk about it a little. So before that, please just uh, I want to see what you are guys do, and let's get started with it. So if any of you guys are okay, please show me what you have, and then we can continue.
Should we go one by one and share our screens?
Yeah, any of you are
Yeah.
okay, please share your screen and we are going on.
I don't know if anyone else might prefer to start, or I don't mind starting.
Yeah, I think nobody was okay by the time, so you can go on. It's okay.
Great. I don't know if what I did was kind of the most, if it had the most interesting output. Wait, let me start by sharing my screen. But I worked on, can you see my screen?
Yeah, we have your screen.
Okay, so I worked on two different definitions. The first definition was to generate the CVS file, which is something I found a little tedious of setting up a CVS file with different relationships.
Mm-hmm.
So what I did was work with the definition I already had of a grid of points, which is this definition here, which extracts kind of all of the neighbor points of one point. Yeah.
Oh, you're working on to generating a CSV file automatically based on the points
yes.
and the relation with the neighbors. Okay.
Exactly. So
it's interesting.
in this case, wait, where's so here I just have a series of kind of 9 points, or a grid of 3 by 3. So here's, I extract kind of like the coordinates of each of the neighbor points and translate them into, so wait, I don't want to mix. And so I translate each coordinate of the neighbor points to the letters of the points, to the names. And I added the room, the CSV number for the Excel file. Basically, in kind of merging all that together, I get this table where I have the room names, some randomly generated areas, and the coordinates of each of the, which are kind of the coordinates of each of the neighbor rooms, if that makes sense. The only issue I had is I had to use semicolons, otherwise it would split up the CVS file. It would split it up into different columns. But basically I have this information here that I managed to just kind of stream as a content.
Yeah, I'm just wondering about the way that it's generating the relations. Could you just?
Yeah. It was for a definition that I already had. It basically kind of breaks down and shifts around.
Could you just please tell me about how you relating these, how you define the relation between the spaces? For example, from the points that you have in the left side of your screen, I want just to talk about them. So you said that it could randomly generate relation between the spaces. So it could
it's not random. Basically, here it just it defines a relation for each point. Each point has a relation with each of its neighbor points. So here, in this case, each point has a relation with every other point. But if I were to take a grid of, let's say, 4 by 4, here, for example,
so
F
you mean
would
that
have a relation.
Each point could have relation between with the eighth neighbor of itself.
Exactly.
Okay? Yeah.
Yes.
So
which is what, which is what you get. I mean, here I have too many. So here I have the relations, and I have 8 different relations.
So
does that make sense?
And what is method is come from? So how you just suggest that each point could have relation between the 8 neighbors. So where it's come from? How you just it just comes from the testing process, or you have any idea about it behind it that you?
I thought it might be interesting to see what it would look like in terms of organization.
So and about
the main idea of it.
If you want to change it and make it smarter, what do you think could be effective? If just do not just considering the 8 neighbors, maybe weighting it.
I think what might be interesting, because here I have, this is where I kind of extract each of the kind of like the top neighbor, the bottom neighbor, neighbor on the left, on the right, and the diagonals. I think it might be interesting to kind of instead of just merging everything together, find some kind of pattern to cull either some of these elements, or I don't know, to create some kind of variation here.
Okay.
I think that might be probably the next step of making something a little more interesting, reducing the number of relations. I think that would be...
Also, even if you can setting the statement that guide the neighbor or setting the statement to controlling the neighbors that are assuming or choosing for the as neighbors for the target space you start. For example, you can categorizing these spaces in the list of some activities, and considering if they are in the same categories of activities, they could be considered as neighbors, for example, I guess, or some other things like this. Or you can setting the some other points in your grid that act as a repulsive, that disconnect the selected spaces from having relation with the selected space that you want to generating the relation from. There are just some kind of cool things that you can do. So maybe some other algorithm could be combined with this. So like
Yeah.
cellular automaton, I think could be a nice choice if we're trying to working in these steps. Like it's just like a pixel and voxel based design that
Yeah.
you consider to create, and we can uh, adding some additional algorithm in it to make it much more robust.
Very interesting.
So
Yeah, for sure.
yeah, yeah, it's a really nice effort. Thank you, Patrick.
Yeah.
It's really it's okay. So do you have any generation from this
Yeah, so
automated?
I generated 3 different CVS files, one with the grid of 3 by 3, one with the 5 by 5, and one with the 7 by 7.
Yeah.
So here I don't remember which one I have loaded here. I'll just load the first one. I think I might have to turn a few things on. Yeah, so here I have the first graph chart. I don't know why this guy isn't. Oh, sorry, here he is.
Yeah.
So the first one isn't necessarily very interesting in terms of organization.
Mhm.
Um,
I think the bias number is not
yeah, sorry.
equal
So
to the
here
space number.
I have my 3 different biases for each of the
Yeah, yeah.
different situations. And then I kind of just set up controls for the start and end points to be able to kind of move them around. But it isn't necessarily very interesting. But I just have this. So I set the control for the start and the end points on either of the kind of angles, the bottom angle or the top angle. The idea being to kind of try and stretch out the solution as much as possible, and then the control points were set kind of within the surface.
Yeah.
I tried to do a first pass with Galapagos in this phase here to what was I doing? I was trying to minimize the distance between I forget which points, and the edge, basically just trying to kind of push all of the points as close as
Yeah.
possible to the
Trying to
periphery.
push the spaces into the edges and the side of
Exactly.
the.
And so then I got my solution, which I think I might have moved stuff around, so it might have been slightly different than this. And then I did a second pass of Galapagos on the bubbles to, I think it was here, to reduce the difference between the
Area
mass
sizes.
addition of the areas of each of these guys and the area of the total boundary to kind of reduce, and then
Yeah.
the layout here. And so then the idea was I tried to kind of reduce the space, the lost space kind of within the square as much as possible.
You said that you want to minimizing
these areas here.
Yeah. You want to reduce
So this
space areas. Yeah.
Yeah, so this what I'm showing here isn't, sorry, isn't the optimized version that I had before. But I have it. No, sorry. I'm not gonna go through all of. I'll just select everything and turn that off. But I made a copy in Rhino.
Hack the spaces together to have less unused spaces. Yeah.
Yeah, and and so that worked pretty well for the 3x3. Then here I just kind of did the 5x5, which ended up with in the layout phase with a lot of overlapping spaces. Not quite sure why, but I thought it was interesting to kind of push to see how it would react with kind of a large number of spaces. And so here again with the 7x7, it got a little crazy.
No, it's great. I have to see these efforts. So, are you okay with the outputs? Do you get the something that you desire from the termite nest? These approaches?
I mean, here in the layout, there are quite a lot of spaces that overlapped.
Oh yeah.
I don't know.
So
I would be in Galapagos. I'd be curious to know if there's a way to avoid that in Galapagos to kind of set, I don't know, some sort of precaution or whatever to avoid Galapagos.
I exactly trying to say something about this today. Sometimes the graph didn't spread it in a way that to avoid this collapse of the spaces in this interval boundary. So you can generate the space, the new points, but with the another solution space that you provide for the spatial after the spatial graph separation. So it would be helpful, I guess. I will talk about it today and share it with you.
Yeah. And there was another kind of question I had. I was wondering if it's possible to get the degree of relationship between each of these rooms with the first room, if it's possible to extract that kind of number or that information. So I mean, this isn't the best.
I don't understand your question about the degree of the relation.
Yes, so I'll just load this guy quickly. So I'm curious to know if, for example, if it's possible to extract for room 20 that he has a degree of 1 of separation with the room 0, and to extract for room 7 that he has a degree of 2. Does that make sense?
Yeah.
I mean, I don't know, and maybe potentially color each of the rooms depending on their closeness or their distance with the starting.
Okay, I think I understand what you said. The graph chart can do this for you. You have it in the top of the definition. The graph chart, I can see the text there on top of them. So the things is that the curve that you connected to the graph chart is it a perpendicular axis of x and y. So
no, I saw it. Yeah, so that was another question when I was setting this guy up. I wasn't sure what curve if it was okay to just use a horizontal line.
Yeah. Displaying the graph chart component, turn the display on. Turn the display of the graph chart on. Yeah. Thank you. So the curve that you set as an input, if being should be a polyline that represents the x and y axis. So if you just if you just drawing the line in the right hand connected to the curve, you can see the differences.
Okay, yeah, sorry. So it should be
perpendicular. That's exactly
a joined polyline.
Yeah.
Okay.
So here, you can stretch it up to present better.
Yeah.
You have lots of spaces. Yeah. So So if you change the index space that you start calculating from, that's connected to the graph maker component
Yeah.
as an space index, start a space index, you can see the steps for each of the spaces in this graph chart.
Sorry, so you'd like me to, so if I change the starting point
Yeah,
here,
yeah.
um,
The maximum number of integration is really high in your graph chart. I think something else is lacking in this. So could you just go up there and show me the
this,
graph chart component again? So you said space names are come from the name of the spaces. Is it okay? So the
yeah,
values and you got the value from the yeah,
letter,
and you got values from the
the
selected
selected,
tree output.
yeah,
Yeah. Uh-huh. I think I found the yeah, the number of the start input start point index uh, here. I don't know why it's happened to
sure, yeah,
the y-axis here. It's not true. Something is not work properly. Could you just send the definition of the grasshopper to I check it much more
yeah,
carefully?
sure. But my main question was, is if it's possible, if there's a way to extract the, this number for each of the different points. Does that make sense?
So yeah, if you connecting the list lens to the output of the selected tree, so it's measuring the steps for you. Just connecting the list lens to the selected tree.
Connecting the what, sorry? The
List
list length
lens, list lens, yeah. So it will calculate the steps for you.
here. Ah, brilliant.
Yeah,
Great. Okay.
it's okay.
Okay. Thank you very much. I'll send you the just
Yeah,
the
please just
grasshopper so you can look at what's going
checking
on
out the
here.
program. Thank you for the nice effort you have. So and your good effort. So
Thank you.
it's really interesting.
Thank you.
Also, Roberto sent me an email and said that he's trying to come back to the Zoom. Maybe there is a problem with their electricity. Yes.
Oh yeah, it's fine.
Just wanted to inform you. Yes. He
Thank
will be
you.
back soon.
Yeah. So any other participant want to share the efforts and the definition that you provided? Carl, do you have any new things to share with us?
No, I just did the exercise from yesterday, which doesn't really add anything new, but it
Yeah,
works.
so yeah, I said please do trying to do some new efforts because if you want to understand that you're okay with thermiteness and checking if you have any question, you can also providing the project like what we did yesterday, and trying to find a new goals for it could be anything, and we will help you in the process. It's okay.
Yep.
Thank you. So, and Danny, do you have anything for us?
Yep, I can show you. I haven't done much. I'm just working today as well. Sorry, I'm just like jumping in between.
Okay.
I kind of did two things. First thing I tried to do with Termite is I tried to kind of create a relationship on the Z as well. So kind of just try to develop a kind of tower type topology through, I guess, the spatial syntax. I'll show you. It doesn't really work that well, but let me.
Yes, please share your screen. I see. Vivid see.
Let me just find it. Sorry, there's just a lot of things open at the moment.
Oh, it's okay.
So I guess the first, oh, can you see that?
Yeah, we have your screen.
Cool. So basically, like I said, I was just trying to create a relationship on the Z, just using, I guess, like the spatial graph to kind of have a series of points, and then try to develop that in a way where I guess it tries to find the best fitness towards a specific area of the site. Exactly what we did yesterday, nothing new, but just trying to find something on the Z. So just using data recorder and just kind of just replicating those steps upwards. So basically, when you change, I guess, the parameters, the closeness towards, I guess, the site boundary, etc., it would kind of just create, I guess, spaces that kind of try to fit that way. But doing that, I guess the limitation is like the control, like all it's really doing is just having like step by step by step by step. It's not really doing anything optimized or anything like that. So I guess, and as well, I tried to put it into, you know, doing the bubble diagram and seeing if I could just make that a bit more efficient, but it kept crashing my computer. It's pretty costly in terms of like computational power, and it was just breaking my thing once we got to like, I don't know, like 20 plus iterations of these things. So I was just thinking maybe doing something a little bit smaller, but also try to you know, develop that kind of on the Z relationship. So thinking maybe I do like a garden thing below, and then on top would be, I guess, living quarters, and then introducing ladybug, trying to find, I guess, amount of sunlight hours on the space, as well as on the Z, the second level, finding, I guess, the massing.
I just want to ask a little question between your talking. So I'm just a little confused about the Z direction you have in your definition. And I saw that your bubble diagrams turns to red one and have some errors. I think, yeah. So could you just tell me that how you treat these spaces in Z direction? Is it just the spaces that come from the first layer that comes in the Z direction, or you define new point separation in each level? So and you call the graph a special graph to generate new points for you in each level?
So that's the thing. I don't call a new graph to create special points. It's just based on the same point, but the way that it's copying up is just recording, I guess, changes in the data. So just using a data recorder, and then just copying that, I guess, iteration or that change up every level on the Z. Does that kind of make sense?
What's the point if you just copy?
Exactly. Exactly. So I guess I was trying to find a relationship for that, and I think I can't think of anything that's justifiable. I was kind of imagining that, I guess, change, a significant change, like say a point moved to another point based on, I guess, relationship or distance to sun or something like that would create, I don't know, a meaningful movement.
I think let me just say what I understand to see if I understand your work correct or not. So you're just creating the topology of the spaces in the first layer, first level, and trying to creating trying to generate a copy of it in the Z direction. But I can see there are some changes in the Z direction of the voxel that you've produced here. If you, could you just zoom in to the
Into
shape in the left side of your
Sure.
screen?
So yeah, so like I said, like every iteration that it changes, let's say the points, they move towards, I guess, a more optimized location. It will copy that to the next Z. So
Oh.
yeah, it's not really doing much, like I said at the start. Like I was just like testing it.
Yeah.
Yeah.
It's nice. So I'm just wondering how can enhance it in a better way to have a better achievement in the output. So use you checking the effectiveness effect of the or the efficiency of the layout in each step. Am I right?
I try to. It's quite rudimentary at the moment.
Okay, maybe we can talk about the process and how you trying to do this process.
Sure.
So the process for you is to there are lots of components here, so I
Yeah.
just want to.
Yeah. So basically, again, like it's just basically the I guess the reason for these movements or why the voxels are moving the way they are is just literally based on a slider that says, oh, it's to be this distance away from it. So then it just makes those, I guess, changes. So I guess if we're looking for a more meaningful justification for these locations and voxels, I think it would be here potentially. I'm just not too sure how I would do that because like, yeah, using the data recorder is limiting because it's like every slider movement is a saved record.
Yeah.
Yeah.
I can send you a better recorder if you want. That is much more compatible. You can define how many items we want to store, and it can delete the last records. It can store the last changes for you, and deleting the past ones. And so I think it's help you to having the better because if you use the every iteration and every steps,
Exactly.
it will use the whole of your RAM memory, so it cause crashes at the end. So if you just limit it to number that you want that can help you, it would be better in these steps.
Yeah, definitely. Yeah, for sure. Yeah, in terms of that control, yeah, I was thinking. I mean, like, yeah, I kind of gave up on this last night, and then kind of started to do something a little bit more real simplified, and that's what I was talking with the garden, potentially just having 2 levels and trying to really like, I guess, hit that relationship between the bottom and the top floor. But I guess if we can do something with this tower type thing, like that could be really interesting as well, potentially, I think.
Yeah.
Maybe.
It would be nice to have this to have to controlling the efficiency in the Z level. So I did some experiences before with timeliness in this process.
Awesome.
Yeah, we have. I think I represented in the first day. We defined geometries and try terminateness to planning the spaces within the geometry that generated in there for us. So yeah, we use the and what exactly we did is we didn't do the whole process within one definition. So we separated into different parts. So in the first steps, we just generating the geometries, and then we implement the and we provide the recursive process that gain the geometries and define planning them and record them as an output. So then we have a tree that we have a lot of geometry with different space plans in them. So we sort them and find the best ones we want from, and we select the desired shapes from them, and then we start to generating and calculating the efficiency of the energy for them. So and so we have the parameters from the geometries. So we have the because if you want to do this whole things together, it takes a lots of memory, CPU, and RAM. So it's really hard for a computer to do this as well in the same process. So when we do it distinctively, so we can have the parameter, we have the outputs, so we can understand that if we want these prototypes and phenotypes in the next iteration, we can generate new things from them. So I think I hope I could help you in these steps.
That'd be
And,
really awesome.
Yeah, okay. So thank you for your effort, and please update me with the result of your definition and to see what will happen.
No worries.
So,
I won't be able to get to this till about after work, so in a couple of hours. So
it's okay. It's fine. Yes, if it takes hours to managing it to work proper, it's not a minute work. Yeah, it's okay. So, what about the Daicha, if I pronounce it well? Am I right in the pronunciation?
Can you hear me?
Yeah, I have your voice.
I just understand yesterday's content by creating new Grasshopper file. So I didn't make new something new for you. Sorry.
You said that you didn't understand the yesterday process.
Yes, but
it's okay.
now I can understand. And this timelessness tool is plugin is so useful for generative design.
So, if you have any question in different steps of the yesterday, please just ask it, and we can make it clarified to you and explain it again. It's okay. It's fine. And just say which part is hard to understand, and we can talk about it more to make it easier for you.
Genome fitness of Grasshopper. Genome fitness. I have never used Grasshopper.
Okay, so that's
So
okay.
it's difficult for me.
I can
Yes,
understand.
it will be a little hard. Okay.
Thank you.
Which part? He said.
He said he hadn't experienced Grasshopper before, so it's a little hard for him.
No, it's okay.
And I think he had trouble with Galapagos, maybe setting the fitness and the genomes. Yes.
Yeah. So I will talk a little more about it now, and then we continue to other participants.
And also, you can use the code that we provided last day, the exercise that Muhammad explained it. So maybe you can start with that code and make some modifications on it. And just please set some simple goals. It's not needed to be very complex or something that couldn't work. So just think simple and make some modifications on the code and try to develop something new. Thank you.
Thank you.
Yeah, it's not necessarily need to be very complicated. You can start with the simple ones, and we will help you to make it much more better. It's okay.
Yes, and one thing that I want to add is that please, our participants try to, after you completed your code, Please just try to make maybe 30 seconds video of how your assignment works, step by step, showing it in just a short video. That would be great. Thank you all.
Thank you, Patrick. I got your GH file. I will check it out for you. Okay, so let's back to the digest. So
Maybe
just
Mohammed, you can. Okay, maybe you can explain it on the code that you wrote yesterday. Just
yeah. I want to open it up and
make it yes. Review.
I'm
Yes.
just sharing my screen to talk about it.
Because the problem is with the recorded file, because we assumed that it would be ready and all of you can use the file, but it had some kind of problem and it would be ready today. So just please don't worry, and we will have the recorded session.
So, okay. So now we have it. Okay, wow, look at this. Okay, so let's just start together from the beginning. So, are you okay with the graph maker and space syntax and what they did? So, there is no question in this part. Am I right? So, okay. So, the special graph is also okay, or it need to be much more clarified. Um, are you okay with the special graph component?
Excuse me, I'm okay with the graph component, but I don't know how to, how was the process of the start and end point?
Yeah, it's okay. I'm just, I will talk about it now, and then we continue. Uh, uh, as you can see, so, Maral, are you okay with the space syntax steps? Is it okay?
Yes,
Okay.
I'm okay.
Yeah. So, what exactly a special graph do, and what I just need to explain a little about what a special graph do to clarifying the start and endpoint rules in it. So you have the space hierarchy as and relation here. So we want to set this graph, which is not in a real world scale, in a scale that show you the spaces within the real boundary to generate DJ plan based on it. So let's consider this two example. I will just trying to show you in the paint. So consider this one, space one, space two, and three, and space zero. I'm just trying to clarify with these four specific spaces here. Um, so if I'm trying to generate these spaces within the specific boundary to see the relation in the real scale, uh, it could be generated in different ways, because here in this graph we set some points to generate a space on it, and this is based on these boundaries. So in the real scale, there is no rules and there is no grids for spaces to generate based on them. So it could be happen. They could be located in different locations. Although they have their correct correlation with the spaces they need to have, but they could be have different locations, and because we have infinite solution space here, and there are lots of points that can be set as location for spaces. So and the way that a spatial graph works is that it generates some random points in this boundary, and it's not really important for it the distance between the points in the first step, and then it tries to locate them in a way that achieve the best distance and also best adjacency with each other. So, and the way that you can control this separation within the boundary is to use the controller point that that aid you and provide this opportunity for you to controlling the whole separation of the whole point separation within the boundary. So, for example, I put in this imaginary things that we just draw here. I'm trying to set the space 0 here. I set the a start point. I set it as a start point, and define its index as index 0, which is when then a spatial graph understands that a space 0 should be located in a place that I set the point start point in there. So then it start the separation of the spaces from this origin, and then I can control the graph direction with the endpoint location. So this just some kind this just like some controller that aid you to control the direction of the point or space separation within the boundary. And it's just it's not necessarily needed to set them as an entry point and the exit point. Here you can set it for different spaces to control the graph in different ways. So if you set the space 4 as your entry, it means that you want to control the graph from the middle of it, and then you can set the other controller as endpoint as index 0 and space 0 to control the left side of the graph if you just consider it in this origin of the from left to right, from the bottom instead of bottom to top. So
is it possible to set endpoint more than 1 point? For example,
No.
2 points as an endpoint?
Yeah, it's not really compatible if you do this. Just understand the 1 point in a better way. Actually, I did not test it yet, but I don't think it's worked because the code is written in a way that it understands 1 point, and it's just the item. It's not understand the list of points. It just got the 1 point.
So how can we set, for example, number 4 as a start point and then control it? Because number 4 is in the middle, and you have to control the top of it and the below.
No, it's the controlling is not really is a hard part, because let me just explain it with example. Let me just disable this rest component. Disable them to not control other spaces. Reset it. Okay. So, okay, as you can see now, it's in the iteration as 0. Spaces location are generated randomly. They are not really accurate. They just set in the space randomly. So, by the way, even in this random selection, it's after the generated, it's try to be in a way that reaching the controller that's set for them to being near to them. So let me just showing the index of the each point. So we said that where is the spaces? I'm just trying to set the index 4 and index 5 or index 0, for example, as a index number of the start and the end. Okay. So, and I want to connecting a point here as a controller of the space 0 and using this point as a controller of the space 4, for example. So it gave me an error. Check your controller index. Where is it? Let me just disabling this. Oh, it's also said that there's another point here. Just excuse me.
Maybe the index of the control points and then the start points are the same.
No, they're different here. I'm just a little confused about the why you're using here. I'm just trying to, let me just try it from scratch. It will be better. We have these are similar. We just want to talk about the rest. Okay. So I'm using this point to control my index 4 and this point to control my index 0. I want to set them to see what happened. Firstly, I select it, and then I'm going to select this point. Four and 0. Okay, so let's see number. You can see this, that as I reset it, it tries to setting the space 4 in a way to being in near of this point, setting the graph in the set in a way that, and the trying to separating the points and generating the graph in a way that space 4 becomes near to this point, and the space 0 to this point. So you can see that there is also some distance here, which is not really accurately point space in space the 0 in the location that my point is, and that's because of the relation that the spaces have with each other and the seed that we use. If I change the seed, you can see it's really different. And that's because, as I said, it tries to generate points randomly in the first step. And then it calculates the distance of the points based on the target value that it calculates from the area of the spaces, and then trying to organize the random generated points in a way to have the accurate distance from each other. And this is a force that work as a resistance that not aid the space to move free in the boundary. So if the one space want to move in this boundary, it needs to push the other spaces because it's the relation force that's connect them together. So and sometimes the force of the rest spaces have a much value that it's result in a way that space 0, for example, in this instance, could not reach the accurate location as the point that we set for it to be located in. We talked about this yesterday with Patrick, I guess, about the threshold and about the threshold that could be added in here to control the power of the start and endpoint location, to set the desired spaces accurately in the position. But by the time the special graph do this by its own, it calculates the threshold based on the relations. And we have a purpose to do this because we want to make these parameters in the first step a little less, and that's and make it much more easy for user to generate the special graph in the first step. And then if it's not really in a way that satisfy the user desired, they can use the controller beside these two control points. But this is exactly how they work. You just setting the point location and setting the index of the spaces which you want to be located in the specific locations, and then a special graph trying to separate the points and generate the graph in a way to set the desired spaces near to the location you provided. So sometimes it's not really work proper, and I explain it. That's because of the relation between the spaces and the force that control and resist spaces to move free within the boundary, because they don't move as individual. They need to every movement means that the whole spaces are moved together, and one space trying to reach the location it wants. So it sometimes make another output that you desire. So you just can change the parameters like seeds and the location of the start and end points in the boundary to reach the goals you want. So is it clear now? Yeah.
Yes, thank you very much. I got it.
Yeah. Okay. So Daichi, you are also becomes much more familiar with special graph, I guess. So let's moving to the generation of the generation with Galapagos and your question about that. Let me just open it again. I just messed up this part. Let I guess. This is another example of evaluation, but it's okay.
Under would be useful.
Excuse me?
Use under.
I can understand. Excuse.
If you want to get back to the last example, I mean, use Control Z.
No, no, it's okay. I'm just open it again. So, so here. Okay, Daichi, and I'm just trying to explain the rest process after the special graph. So we said that we want to locating some of our spaces in this project. We want to set our bedrooms in a way to being adjacent to the this age and this age. So we extracting these edges from the boundary that we draw firstly. And I don't know you are familiar with this component and how they work. Are you okay with this part? Yeah, so we explode. Yeah, also it's okay. So, and then we're trying to generate 3 points here. You can see. Yeah. We're trying to generate points, 2 points like this. I set it here. Yes, 3 points. One is in the top here and 2 in the bottom. So we're trying to generate 3 points on this curve, and these are the locations that could be as the location our spaces could be set to, and while we reducing the distance between this location, for example, or we see a space 4 we have here, it means that our space is now in the our space is accurately in the location that is near to this edge. So we find the way that we're trying to interact with machine and just understanding the distance. We set the points, we calculate the distance here. Here with this component, we said that please calculating the distance between the spaces we select and the points we generated in on the curve. So after a special graph generated the graph, we can measuring the distance it provided for us. And trying to minimizing this distance. So the Galapagos and the genetic algorithm work in a way that it will trying to reduce or enhance the target that we set for it. So if we want to setting the goal and trying to optimize a problem or trying to optimize the solution that we provide, we need to think in a way that the target that we follow just can be minimized or maximized. So in this example, we define the distance. So in this way, we can say the genetic algorithm to minimizing the distance. And if it's minimize the distance, it means that we reach our goals. As it's minimized better, we reach the better output. So, and about the viewport we have here in the Galapagos editor, are you familiar with these parameters? So it's okay. This is not the part that we want to really talk about in this workshop, but I'm just trying to introducing them. generally. So here you have the fitness goal, which we talk about, and we can set it to maximize or minimize. So we want to minimize the distance. The threshold is the value that that defines the accuracy of the value that we're trying to find. If the value is, for example, we can set that it's in the decimal or in the integer, that set if the value that genetic finds after the minimizing in 100 steps and 100 iteration and for 5 generation is in a threshold of 1 decimal with the goals that we define, and the iteration does not change in the after that really uh, efficient. Genetic algorithm will stop, and we can see the result. Another way to stop the genetic algorithm is to setting the limitation of time for it, to stop the generation and calculation after the time we provided here. This is evolutionary solver, and this is where we setting the population and initial boost. You need to have understanding about the process of the genetic algorithm to understand about it. The genetic algorithm actually totally work in a way that it generates a random population in the first step. Then it tries to set them in the function and calculate the result, and then it will sort it in the value of the fitness to see the result of them, and then trying to select from them for the next generation and next iteration. And it's and it have two way to do this. It can crossovering the result, or it can muting the individual it can mutate the individual parameter. So in this way, in this step, we just setting that we want to we can in the first step generating the 30 item, and when we set the initial boost, it's multiplying these numbers and trying to for example, if I set it to 20 and 50, it generates 100 of them, and calculate them 15 in each in iteration, and then it's try to maintaining the 5% of the results that calculated in this step. And for example, if you have 100 results or genotype in the first iteration, it just maintaining 5 of them and trying to make the rest based on them. So this is just the basic information about the genetic algorithm setting and how it works. So if you want, we can share you documentation about the genetic algorithm to have a better understanding about it. So the thing that we work here and we really need to know is how we use this genetic optimization to reaching the target we defined for the spatial graph to act in this way. So did you just satisfied with this explanation, or is there any question yet?
Thank you. I got it.
Yeah, okay.
Thank you.
So please trying to do an example with the format of this project or any other simpler. And share it with us to see the problem or the question you may face with during the process to solve it together. And thank you. It's okay. This may just.
Okay, anyone else having any trouble or question? Roberto, do you have any question?
I have a lot, but it's more the problem that I have with the algorithm. I just can't make it run. When I try, I actually sent some images to first while you were explaining to Daichi. I just wasn't able to run it. I had so many errors. I actually reinstalled the plugin for it, but I wasn't able to solve it. So if you have time just later to check the algorithm with me, Mohammed, I will be grateful. I can wait, don't worry.
Yeah, it's okay. I just have your voice very
Unclear?
oh yeah, it's not very clear. It's very low. Yeah.
Can you hear me now better? Wait, let
Yeah,
me.
it's better now. So Robert, do you
I'm sorry.
did you? Yeah, it's okay. Did you provide an example for us today?
No, I actually I wasn't able to do anything because I wasn't able to run the definition well. What I wanted to do was try to dominate first the example that you sent us, but I wasn't able to run it, so that's why I
Okay, well,
couldn't.
this is CSV file. Yeah.
Yeah, well, I was able to solve that, just writing again and again the lists of the CSV files, but then I started to have errors with the bubble diagram. All of the perimeters that I started to draw, none of them were working at all. So I wasn't able to run it.
Oh,
And
so
maybe it
yeah,
would be good if you share your screen, Roberto,
Yeah, of
because
course. Let me share it.
yes,
Just wait. Okay, let me know when you can see it.
yeah, I
yes,
can
we can see.
Okay, as I told you, I wasn't able to work at all because I wanted first to dominate all
yeah.
of the features of the script that you gave us. When I tried to change everything, to change the parameters, this component just didn't work, just didn't run. It always gave me this error, even though I changed the parameter and the perimeter of the that I had to draw for the
Yeah.
for the bubble diagram. For
So,
example,
yeah.
if I start to draw something like this, I don't know. For example, this maybe bigger, and if I set it here, the error still comes out. I try to change these parameters. This happens. It starts to blink, as if in some moment it starts to work, but the same error still is coming out.
Okay. So let me just see the iteration step that you set to the special graph, please.
Okay, these ones are okay, but I don't know if maybe the problem is there, because I actually
No, no, no.
changed
The
this.
iteration is what is the iteration is step that you set to the special graph?
Oh, I see, I see. It's, let me check. Um, two,
No,
step two.
the special graph. It's 2. So let's just set it to 0 and then set it to 1 again. So,
I think
okay.
it has started working. Yeah.
No, no. Could you just give me the access to control the definition?
Of course. Okay, I gave you access.
Yeah. Thank you. So let me just have it in here. See what we got there. We have 12 of them. It's okay.
Okay. Fine.
I tried that again, but
Yeah.
for me it didn't work either.
I want us to see that why there are so many points in here. So we just have to see 3 points in the edges that you've
I
selected.
see. I didn't add any component. I just used it as you deliver it. The quantity of points have always been the same.
So we have 3 points here, but what are these points?
Those points, it seems that they are going for the control, and some of them are going to be endpoints on the special graph.
No, you can see that they are not in the special graph list.
No, most of them are on the controller, but if you put it in the controller, they should come up if you click on the special graph.
No. If I select this, you can see that I'm just selecting these three.
Yeah.
And when I select this component, you can see that the rest here are selected. And
Mhm.
space 8 is sitting so far, and that's because of this. Space 8 is located here individually and is not related to any of those other spaces. You can see this.
Yes,
So
it's not grafted to the graph.
yeah, and the bubble diagram cannot generate the bubble because it's allocated individually there. So I want to check out what's the problem with the space 8 here.
Do you think that it will be the CSV file? Because I checked all the relationships. I don't remember having the 8 isolated from the relationships of the spaces.
Let me just
But I
check.
don't know. Maybe. Do you want me to give you access to the CSV file?
No, I can select it here.
Okay, that's the one that I have been using. Do you want to open it? Yeah, there.
Yeah.
Let me give you access to it because it's on the other screen. Here it is.
Yeah.
Oh, there's no 8 there, man. In the
Yeah.
relationship. Maybe that's the problem.
Yeah.
Okay, so it's the bathroom, the one. So maybe just relating that space with another one will maybe
Just
solve that.
randomly just testing how it's worked.
Okay. So should I change it for you?
Yeah,
I'm
please.
going to put it here on the.
Change it anywhere you want.
Okay, save. I see.
So please. Yeah. And we still have the 8 here.
You still have control if you want to check.
Yeah. Thank you. I have the control now.
Yeah. It says that you have control still in the computer.
So now we can see that space 8 is related to 2 spaces here.
No, it isn't. I mean, 8 is still far from the graph.
Checking the space syntax graph, I want to see how it works.
Oh, I see.
So it's also related here, space syntax graph in the right side. Here you can see that it's related to 2 spaces, and it's really weird too. It's located individually in the boundary. Let's check it again. I can move the grasshopper scene. Are you sure that I am connected?
Yes, you're connected, but let me just stop the control. Don't worry, and I'll share with you again. Okay, I sent you the request.
Yeah, yeah. Thank you. So we just set it in this boundary. Where is the boundary region? Oh, it's a
What?
bit more. Why?
Can I just say something maybe?
Yeah. Okay.
Because I also got the same error message a few times, and
So
I think it has to do with the area of the boundary being too small. At least
the
that's
area
what
is small.
happened a few times in my case.
Actually,
Uh-huh.
Patrick, yesterday when I was working with it, it came out the same error. I tried the same as you're saying, and it worked. But for this algorithm in particular, it didn't work. It just started to do the same this thing, just taking out relationships between spaces. I
Okay.
tried to make it bigger, and it didn't work.
I didn't think it's about the area because it's calculating the graph, but it's isolating the 8 space individually here, and it's not related to other. It's weird. I want to see what we have, and we have also some points here which are not really, which I don't where they come from. I want to see what is going on here. So let me just are you okay if you are trying to write it from the scratch with the same
Yeah, of
CSV
course.
file?
Yeah, let me do it, and I'll let you know when I have it ready. Don't worry.
Yeah, I want to see why it's will. So do not use the evaluate curve. So just trying to assign some points that you gain from the rhinoceros and try it, and then we're trying to set these uh, controller from the evaluation to see what will happen.
Okay, so do you want me to do that? Should I just look for some points and then start to put it on the controller?
Yeah. Let me just see that what will happen, and try it again.
Okay. Do you want me to write again the CSV as well?
No. It's the same CSV. I want to check out if it is a process problem with the components or not. I think the CSV is okay. And send me the CSV file, please, that you wrote.
Okay. Okay. I'm going to stop sharing, and I'm going to do what you told me right now.
Yeah. Thank you.
No, thank you.
So, Patrick, you said that you moving the input curves of the graph chart and it's solved, but it comes again, huh?
Yeah, no, I don't know what happened. I moved the curves from the graph maker, and it disappeared. But then when I did Control Z to make a screenshot for you, and then they all came back, and I couldn't make them go away. So I don't know why they. So I don't know what happened.
Yeah. Let me just open the sample file that you sent to me.
I mean, I tried moving it, scaling it, and in several directions, but I still get all of the nodes and the numbers repeating on both axes.
Let me just check it. So I just opened the file that you sent to me. Oh, you don't have my screen. Let me just share it. Yeah, you have it now?
Yes.
Yeah. So I'm just trying with the example with the CSV file that I have.
Yeah, I didn't send you my CSV file. Sorry.
Yeah, yeah. Okay. It seems okay in this with this CSV file. Let me just have your CSV file to check it with that.
Yeah, I just sent it.
Yeah, thank you. I will check it. Okay. I think there's lots of spaces in it.
Yeah,
Oh, yeah.
it's a little heavy. That works.
Yeah, it works properly here. Yeah. Let me just changing the boundary of the graph. So now you can see here, I'm just setting a regular polyline to the graph chart, and it shows the steps of the iteration carefully and right. So I think maybe you have a problem with the inputted curve. I'm just internalizing it for you and send it back to you to check it out if it's work.
Okay, but no, I also have it's the curve I drew in Rhino, so I don't know. It should be the same.
Yeah, I'm just internalizing the curve I inputted here and send it back to you to see what will happen.
Yep.
Let me just set it also for it. How many spaces you have in your CSV file?
There are 49. Yeah, 7 by 7.
Yeah. Let me just save it again. What is the name of the definition you sent to me? This is, I guess.
Yes, that's it.
Is it okay now?
All right, it's opening. Sorry.
So it's in the calculation phase, or it represents the result?
Sorry, no, it's still loading the. It's a little slow. Sorry. So
Okay.
yes, it's okay. No, I can see it.
Yeah,
Yeah,
it's
it
okay.
works.
Yeah, I think it's just problem with the polyline you set for the graph to draw the iteration
Does it
on it.
matter does it matter maybe the direction in which you draw it, or
No, the direction is not really matter, but the curve or the edges should be perpendicular to each other and need to be straight in the direction. If you have any angle in the direction, it will have some errors.
okay?
So yeah, it's okay, fine.
Yeah,
So
it's fine.
thank you.
Thank you.
I think we can go have some rest and come back to check the other participants' works. Moral, Mina, and Kamir are being ready to show us their efforts and example in the next.
Yes, sure. We can have a break, and after 2 hours, we will be back. Please feel free to ask any questions or if you have any confusion with the algorithm or each step that we had and explained during these 3 days. So please just feel free to ask your questions, and we hope you have outcomes and assignments. So we will discuss it together, and as I told, we will have a 30 minutes just a short video of your outcome, and this would be very great for us to have your collaboration. So just let's go to the break, and we will be back in 2 hours.
Great. There's just one thing that there's one thing that I'd like to hear about later on is the process that you go through to kind of keep track of the different iterations that you make, or kind of export them from Grasshopper to Rhino. I mean, I had to kind of create a lot of components attached to your termite components to kind of bake to Rhino. I don't know if there's I don't just make a specific methodology that you guys
Means that
use.
the component that aid you to baking the iteration outputs in the Rhino scene layers.
Yeah, I mean, for example, or I mean, if you guys have any specific method to maybe, I don't know, export different iterations, like a series of different iterations at once, or I think that might be interesting to hear about.
Yeah, we can talk about it in the rest 3 hours and try some method together.
Great, thank you very much.
Yes.
Yeah, it's okay, fine.
Okay.
So
See you soon in 2 hours.
yeah, goodbye. Bye now.